Here's an example I have. We have two different proportions. Our claim is that we're going to have proportion 1 be strictly greater than proportion 2. And if we find significant evidence of that, we'll be able to conclude that it does. If we do not find said evidence, then we'll be stuck with our null hypothesis where P1 equals P2. Now, first we have to check to see if our n values are sufficiently large enough. So we need n1 times p1 and n1 times q1 to be greater than or equal to 15, or each of those individually too. And we need the same thing for the second proportion. Well, since n1 times p1 is effectively x1, because p hat is x over n, we need the number of successes to be 15 or more, and then the number of failures, so that would be our n times q, to be at least 15. So we have 368, that's well above 15. And 541 minus 368 is 173, so that's above 15. And the same thing will work for the second proportion. So we get to use the z-distribution. Now, determining the calculated function we're going to use, we're dealing with two proportions. That's the large sample for p1 equaling p2. This will be our test statistic, and that will be calculated by our 2-prop z test. So that's what we're going to run in the calculator. Alright, so stat tests, 2-prop z test. I have all the information entered. x1 is 368, n1 541, and so forth. If you're in a situation where instead of using the values of x and n, you're given p hat and n, remember that you just need to multiply those in the x values. If it turns out to be not an integer, or not a whole number anyway, then you need to round that, otherwise the calculator won't work for you. Alright, and we have to choose among these. We are choosing the greater than. We're looking for P1 greater than P2, so we're good here. If not, you would need to highlight this one by moving over and hitting enter. Alright, so we'll get our test statistic and p-value here. The test statistic is 3.08. The p-value is 0.001. Alright, so that's what we got from our calculator, 3.08 and 0.001. Again, all of these are the summaries, and this is the p-hat, which is our pooled proportions. Now, we need to find a rejection region, and there will be only one since it is a right-tailed test. We take the entire level of alpha and put it in the right side, so we'll use the inverse norm of 0.05. Now that gives us a critical value. If it was a left tail at negative 1.645, we're going to use it on the right at positive. About there. So that's our value for the critical value. And our rejection region is strictly on the right side. So there's our rejection region. Alright, so we have a test statistic and we have a rejection region, so we compare the two, and this falls right around here. So just over 3, so we reject. Another thing we can look at here is our p-value. We compare that to alpha. Well, in this case, we're less than. All right. And our third method would be a confidence interval. Now, we can't take a 95% confidence interval, even though alpha is 0.05, it's not going to work. It may work in this case, but in order to be consistent, we need to do a confidence interval that has 0.05 in each of the tails. So I'm going to try a 90% confidence interval to do testing as well. Alright, so we want Alright, so we want a 90% confidence interval. And 2 prop z int is what we'll use for confidence intervals. Again, this is large sample for p1 minus p2. This is the formula that we would use, and this is the calculator function. So stat tests, we need to go ahead and 2 prop z ints. 1 prop, there's 2 props, it's a b. And all the information should be the same. What we need to change is the confidence level. This should go to 0.90. And 0.042 to 0.135. So there's our confidence interval. We have a strictly greater than. Both of these are positive. So 0 is not within the confidence interval, and it's strictly greater than 0, so we can reject as well. And again, all 3 of our testing methods provided the same results. If this isn't the case, then something is wrong with your math or in your testing procedure somewhere. They're all supposed to have the exact same answer.